So the next thing that I want to talk about, since we've already had our first proof, is another way of proving or coming to a conclusion based on our given information is a paragraph proof. So let's look at what that is. So here we can see two angles, angle O and angle P. And let's say that we're given the information that angle O is equal to 67 and 1/2 degrees, rather. And angle P is equal to 67 degrees and 30 minutes. All right, so you may or may not have seen this notation before, but we're going to talk about that in a moment. So we're asked here to prove. How about we prove that the angle O is congruent to angle P. So we have to prove that angle O is congruent to angle P. All right, so let's see what that looks like. And we're going to prove this using a paragraph proof. And okay, sorry, I'm just changing my color here. All right, so we have our proof, and so you may know already is that there are 60 minutes in 1 degree. So that's the notation that I was talking about earlier. So if angle P is 67 degrees and 30 minutes, well, we first need to state the fact that there are 60 minutes in 1 degree. So we can say since there are 60 minutes in 1 degree, 67 degrees and 30 minutes equals 67 and 1/2 degrees. Oops. And then we can say since angle O and angle P have the same measure, they are congruent. All right, so pretty simple. It's not the most complicated proof in the world, but this gives you an idea of how a paragraph proof kind of lays out. So you're given some information, you need to prove the same kind of information. It's just easier in this situation to prove it in a paragraph proof because we can really explain what we're talking about. So well, since there are 60 minutes in 1 degree, it's not really so much as a statement and reason, and it's not really the same as the proof we looked at in the last lesson, but it's a way of us trying to explain logically. Since there are 60 minutes in 1 degree, then 67 degrees and 30 minutes is the same as 67 and 1/2 degrees, and then they have the same measure and they're congruent. So similar, but a little bit different. Sorry, I had to restart there. Student walked in yelling about something or other. So what we were talking about is with this proof is that you can really start seeing that geometry is based on this very deductive structure. If P, then Q. That this deductive structure is a system of thought where conclusions are justified by the means of previously assumed or proven statements. So let's actually write that out. So we have this deductive structure of geometry, which is a system of thought in which conclusions, let's take this down, which conclusions are justified by means of previously assumed or proved statements. I would say that this deductive structure really has 4 elements about it. 4 elements. And these can be classified as undefined terms and assumptions, or known as postulates. And then a postulate is just an unproved assumption. So some unproved assumption. We have definitions. And then we have theorems and other conclusions. So, so this is something to think about. This is another thing that to keep in mind when looking at proofs and things that we're going to be working on problems that we're going to be working on soon here in geometry. And I mentioned before the idea of if P then Q, or if Q then P. So what that's actually referred to, let me get a different color here. So what that's actually referred to is a converse. So you can have a converse, which is if Q, then P. Right? So if some event Q, then some event P. But there's also an inverse, and you might be able to deduce that an inverse is something of the sort, if not P, then Q. And we'll write that in a moment. Just want to type this really quick. And then lastly, we have a contrapositive, which is if not Q, then not P. Right? So initially we have if Q, then P. And I'm just going to change to my brush tool. And then we have if not, so an inverse would be if not P, then not Q. So that symbol there is denotes not. So if not P, or then not Q. And then the contrapositive, lastly, we have if not Q, then not P.